Thank you, Joe. As Joe mentioned earlier, both survey and GIS are important aspects of this aerial industry. And I'm going to talk about how BPG was able to integrate those two aspects of it to improve both our processes and our deliverables for our clients. So my name is Brandon Sisco. I'm the BPG's mapping project manager. I manage all of our surveyors and our GIS teams. And I'm going to talk about how we've integrated those survey and permitting activities for our aerial utilities. For our agenda today, I'm going to talk about kind of why we do this sort of collection and what our old process was. Then I'm going to go into kind of why we needed to change, what about the industry was changing that forced us to update our processes. Then I'm going to talk about our new approach. And then we're going to get into the benefits of that new approach and how it's really helped us. And then I'm going to talk a little bit about the advantages and disadvantages of the process, because they're both and they're important for people to understand if they want to make that type of change. So for BPG, we are a telecommunications design and build company based out of Phoenix, Arizona. Our primary role is to design and build fiber optic networks for large network providers. In Phoenix, it used to be that companies could strap anything they wanted to with a pole, strap anything they wanted to on a pole, and just kind of build their networks that way. But as the infrastructure started to get larger and larger, the process for aerial permitting got a lot more scrutiny to make sure that everything was going to be able to work well together. Also, as more and more of this infrastructure got built, a lot of the fiber optic was supposed to be underground, but there's a lot less room underground, so people started to move aerials and putting them on the poles. So more and more of those segments were becoming aerial segments and had to get onto poles. Now, we also do, BPG also does mobile LiDAR collection, and we do that for a lot of our larger jobs. But what I'm going to be focusing on today is a lot of our smaller jobs where the mobile LiDAR system is not necessarily as efficient. So that's kind of where I'm going to be spending my focus on it. But the mobile LiDAR does go through a very similar process in our organization. Okay, so how we had always done it. This is probably a typical day for a lot of field collection personnel. They'd come into the office, they'd meet with their team leads or the PM. They'd grab a stack full of blank papers of the collection forms. They'd drive out to different addresses and locations, find the poles that they were looking for. They would collect the information that was required. In our case, we were looking specifically at the pole connections. So for power and utility connections, we wanted that height above the ground. All this information was recorded by hand. They would write all the information down on the paper. Once they were complete, they'd return back to the office. They'd give the copies of those paperwork to the team leads. And then that team lead would then have to go and enter everything into the system by hand. Later that night, they'd get a call from the team lead that would say, hey, is this a 6 or an 8? Is this a 0? What is this? And then they'd get told, hey, you grabbed the wrong information for this client, and so now you have to go back out there and do it again tomorrow. So it was a very labor-intensive and very manual process. You know, just the handwritten to digital transcription was a major task for our team leads, and that took up the majority of their days. There was also a high degree of probability, or sorry, a high probability of error during that transcription, because not only did they have to read and understand the handwriting, but then if they actually typed in the wrong number, then there was another error there. Even the cost of just going through reams and reams of paper, of printing these out and sending them out into the field. If our collectors finished the tasking for the day, they had to drive all the way back to the office, get their new tasking, and then drive back out into the field to continue collecting. So if they finished early, they'd waste a lot of time coming back to get more tasking. And for us, that was just a lot of costly remobilization and just mobilization in general. Phoenix is a large city, and driving from one side of the city to the next for a different job, it took a lot of their day. our team leads and our project managers didn't really have a lot of information to go off of, so the job priority was the due date. So they would schedule everything by due date. So whatever was due soonest got done first, and that was the only method with which they had to really separate out how to dispatch the jobs. And the last thing is, and we'll talk about this a little bit later, is that the data is only good for one job. If we go out and we collect a poll, we write it down, we come back, we transcribe it. If in 2 months we have to go back out and recollect the same poll for a different client or a different purpose, all that previous data is gone. It's in the trash. So we can't really enjoy any of the benefits of having already collected that poll and that information. So that was just a waste of time, and we have to go back out and do it again. So these are kind of the way we used to do things, and it wasn't working out for us. So as the situation started to develop, we figured out we needed a new way. Some of the reasons that we needed a new way were we provide a lot of information to different customers and different types of collection for different customers. Some of our customers are looking to put small cells up on light poles. Some of them are looking to put them up on power poles. Some of them are looking to string fiber for their networks across poles. So a lot of these different collection types require, a lot of the different purposes require different collection types, and each customer had slightly different requirements. And so as those started to increase, it became harder and harder to keep track of what was needed to collect. For the utility companies, the collection requirements were increasing. Like I said, more and more utilities were going up onto these poles. Wind loading started to become a real factor for these companies. So now, in order to be able to do wind loading, we had to collect even more information for the utility company. So as these collection requirements started to increase based on the type of collection, the clients, the utility companies, our old method was really starting to fall behind. Also, because we were doing what I consider to be a fantastic job for our clients, they started to ask us to do these in more and more locations. So, for instance, we started to do more work down in Tucson for these types of collections. Well, if you're not familiar with Arizona, that's an hour and a half to 2 hours each way for our collectors. So any issues with not having the correct information or needing to go back was a very significant problem. Our clients, they wanted more visibility on the work as it was getting done. They didn't want to wait and get everything at one time, a month down the road or something like that. So they wanted to be able to see as things were going along, how things were progressing. They wanted to go back and be able to check things and look up different pieces of data on their own. And finally, as our own internal management, they wanted to reduce mobilization times. It was becoming a larger and larger cost for us. So they wanted us to figure out a way to reduce these mobilization times. So what we started to look at was kind of integrating what we already had. We didn't want to have to go out and buy a new system. We didn't have to want to buy new tools. So we started to look at how can we create a better process based on the tools that we currently have available. And so here's a list of the tools that we had, and we were able to kind of string together to make our process. And it's all built on an Esri backbone, and it's that Arc Enterprise that you can see there on the screen. Then we have a Postgres database to house all our data. We have customized web applications, and those can be customized for the different clients, the different collection types. And the nice thing about that is, even though they all look different and serve a slightly different function, they all point back to the same database. So all that information is being stored in one location, and that it makes it easier to manage and easier to reuse. Art Collector is how we collect our software, and we use a lot of tablets and smartphones that do our collection out for a lot of this type of collection. And the reason that we're able to do that is through the use of the Bad Elf surveyor. It's a small, lightweight piece of equipment that allows us to integrate our iPads with the collector to collect the information much more efficiently and quickly while getting it into our process. And I'll talk more about that later. We use the Leica Disto as our rangefinder, but the real benefit of our process is not in the method with which we measure the items, it's how we're dispatching and how we're able to collect the data and get the data into our system. If you had a telescoping rod, you could use that just fine with this sort of system, and it would be just as efficient. So the method of measuring is really agnostic of our process, so that helps us as well. If we have to change out a tool, our entire process doesn't have to change. And then we use AutoCAD and Excel for some of our products to our clients, and I'll talk about how our process really fits in with those two pieces of software to help us with the automation. Okay, so we've talked about how our old process was inefficient and why it needed to change. Now I'm going to talk about a little bit about how it actually changed and what we're using now. So for now in our organization, we have one primary contact for each client. They take the request from the client and they input that request into a central web application. And so everybody inputs their data to one application, and this really lets our collectors and our survey team lead know how to dispatch and what his workload looks like for each day. So this is his one-stop shopping to go to figure out where to send his collectors. He takes a look at the dashboard every single day, dispatches out his work to OneNote, and sends that out every evening. In the evening, the surveyors can look at the OneNote, figure out what their tasking is for the next day, and when they wake up in the morning, they just drive straight to the job. They don't have to come to the office to collect materials. They don't have to come to collect tools. They drive straight to their jobs. Now, the nice thing about this is where this has really helped us out is now the team lead and the dispatcher can look at how jobs are located spatially, not just by due date. So yes, it's important that we hit our due dates, and that's the first priority. But now we can look and see if there's 3 or 4 jobs located near each other, we can assign that to one collector and significantly reduce his mobilization time. It also allows us to assign jobs based on areas near where our surveyors live. And so what this does is allows them to have a shorter mobilization time to their jobs, get things taken care of, and then head back home, again, significantly reducing our mobilization while still hitting all of our due dates. So that has been one of the big benefits of moving to this type of system. Okay, so before we would send people out, they would take kind of their traditional survey equipment out with them, set everything up, and do a traditional survey and do a telescoping rod. We eventually moved to the Leica Disto for a laser rangefinder measurement. But really, the tool that's helped us the most in this process is this Bad Elf Surveyor. You can see there that it's small, it's accurate, but the nice thing about it is that it seamlessly integrates with an iPad or an iPhone to their internal GPS and kind of overwrites that internal GPS. So now, when our collectors use their tablet to put down a point, it pulls the information directly from the Bad Elf Surveyor, and now there's no transcription errors. The lat long is directly plugged in. They don't have to spend the time typing it in. They don't have to worry about making mistakes. They don't have to worry about switching latitude and longitude. Everything comes in automatically, and that information's correct directly from the unit without having to be affected by the user. So that's been one of the biggest benefits to moving to this type of a system, was having that information automatically pulled in, reducing the probability that someone's going to fat finger latitude and longitude, and just putting everything exactly where it needs to be, excuse me, for the collector. So as you can see, in the end, that bottom picture there shows all our collectors are taking out into the field is a tablet, the surveyor, the Bad surveyor, like a rangefinder, and then the only thing not pictured is a tripod. So it's significantly reduced what they have to take into the field. So now, one of the big benefits for using collector in this type of system, like I said, we can get the latitude and longitude, but also this allows us to control our data. And what that does is it provides us data integrity. We can limit what a surveyor is allowed to put into the system. We can validate that information directly so that instead of allowing them to put bad data into the system, we can prevent them from doing that, make them fix it before they even submit that data. One example of this is in Phoenix, there are about 25 types of poles and height combinations that we typically collect. So you can see there on that right picture, there's an option for the surveyor that says pole size. That's actually a drop-down menu with all those combinations. So now the surveyor can just open the drop-down menu, select what they need, and move on. But the system is also flexible enough that if they're collecting something that is not one of our standard options, they can still write it in under that column, under that attribute that says pole size other. So this gives us the data integrity that we need, but it also allows us the flexibility to handle any situations that come up that are not necessarily those standard collections. So not only does it help the surveyor collect the information, not only does it help the team lead with dealing with the data back in the office, but by having this formatted data exactly the same way every single time, we've been able to automate a large portion of the back-end process so that we're taking a lot of that out of the hands of the team leads and the PMs, because all the data comes in exactly the same every single time. So those are some of the big benefits for us to using collector. Other reasons that we like to use collector are, you can see there that we can simply take a photo using the integrated camera for the tablet or the smartphone. If we have any documents that need to be attached, we can put them in right there with those. So it's really kind of a one-stop shopping for the surveyor to add any information that they need to that point. And then as soon as they hit submit, that information is immediately available back in the office. So our team leads and that can have access to the data, but they can also monitor the progress of our surveyors and see where they're at and what they've been collecting. So like I've talked about with the location, the latitude and longitudes get updated through the Bad Elf. We can add those photos. One of the nice things that isn't really thought of necessarily is, you can see on the picture on the right, we received a latitude and longitude from our customer for a proposed small cell site, and that's the triangle in blue. However, when our surveyor went out to collect the information, it was actually located at the green circle. Well, because we have our Bad Elf surveyor, we were able to put that point in the exact location that it was for, collect all the information that was needed, and now both BPG and our client have a better understanding of where that pole truly is for the design aspect. So it helps them get real life data rather than approximate data. And so that helps with the design aspect. Through the use of the collector, we can tailor what our surveyor sees and doesn't see, give them options. So we can do something, we can add in a layer that has our utility company boundaries. This way, if they're working near a boundary, they can turn that layer on, collect the required information for one company, and then if they cross that border, they can change what they're collecting, and they can go to the next company's requirements and collect that information. So now there's no need to collect extra information. We can, or not enough information. We can collect exactly what's needed by knowing exactly where they're at. And then finally, one of the big benefits of this again is that our data is not dumb. So if we've collected a poll before, we can open that poll up, verify the information that's there, take a new picture, and resubmit. And so now instead of having to rewrite and recollect all the information, we can just verify, resubmit, and now we're back up and running a little bit faster without having to recollect all that information. So that's kind of one of the nice things about being able to reuse that information is we still want to verify that it's still correct, but it's a lot faster than trying to recollect all the information a second time. Once all the collection is complete, we get to do kind of what I consider the fun stuff, the fun GIS-y stuff. Once all that information is in our web application, our team lead now gets to go in and actually start using it. So for instance, for us in Phoenix and probably in a lot of markets, we can't permit fiber optic utilities around a 90-degree corner for wind loading purposes. So by having all the information in the system, the team lead can simply select the poles that they're interested in, export those out, and only use those poles. And then when they do the second portion of the permit, they select the next portion of the poles that they're looking for, and they continue on with that portion of the permit. So it's all very interactive for them, and they can get exactly what they need without having, again, to collect too much information or not enough. So they can go through, they can sort by their jobs, they can select the ones that they need. In some of the applications that we have, the colors will actually turn, the symbols will actually change colors when collection has been completed. So again, the team lead, the person that's doing the permitting, knows exactly this one has been completed, this one has not, and so they can get what they need and export all that information directly from the web application itself. They don't have to look around, they don't have to add paper or transcribe anything. They just pull it directly out of the website. So as I said, because all of our data is now in a formatted database in exactly the same way, we can use it for, we can start to automate those processes. Now we have two primary processes at this point in time. One of them is a small cell permit, and there's a portion that we have to do manually via AutoCAD, where we'll put in the information that's needed and kind of change up the template a little bit. But once we've got that framework completed for that specific pole or the poles that we're looking at, we can actually then automate creating the customer's specific deliverable. And so the person doing the drafting will select the poles that they need and run this process using the Python code, and it will create the deliverables for all the poles, and it saves 50 to 60% of the time because before it was simply just going through and recreating a very similar document over and over and over again for each pole. But now we've been able to automate that process and save a significant amount of time. And then if the customer asks for something slightly different, we can change the template and still use our process without having to update too much of that. For our aerial fiber permitting, again, that's kind of one of the ones that we do most of the time. The team lead will export the information from the website, and then we have an Excel macro that automates approximately 80% of their permit and 80% of their workload. There's still a manual process because they have to go in and look at pictures to see if there's you know, a fraying, or they have to go in and look and see if there's nests or things of that nature. But all of the manual typing, all of the calculating distances, and if something is too close or if it has to be moved, All of that's done through automation now. And so it's significantly reduced the number of errors and increased our productivity because the data is in a standard format for us. Okay, disadvantages. I wish that we could say that there are none, but we do have some disadvantages to our process. By moving to tablets and iPads, they overheat. Apple says they can stand up to about 95 degrees Fahrenheit. If you're lucky enough to not be in the Phoenix area, sometimes 95 degrees comes at about 9 o'clock in the morning. It gets pretty hot during the summertime. So our surveyors, when the tablets overheat, they'll go back to their trucks, they'll cool it off. The nice thing about it is it's also kind of a safety break for them, so they can get water, they can cool off. So it's not a huge loss of production because we're also incorporating that safety break aspect to it. Another aspect, though, is if you have to plan out everything before you get it set up. So you can't just start putting data in. You have to understand, what am I going to collect for each type of collection? And then if something changes, whether it's a requirement, a customer request, sometimes those can affect a lot of different macros or the web applications themselves. And you have to kind of go through and make some of those changes, which can be pretty extensive in some cases. But overall, the advantages significantly outweigh our disadvantages. One of the biggest ones was reducing our mobilization time by becoming more efficient in our dispatching. This has been one of our biggest cost reducers for us, is to be able to dispatch spatially rather than just by due dates. We have faster access to actionable information. The office doesn't have to wait till the end of the day for the surveyor to come in and drop off the paper. We have it as soon as they're done collecting the data. Reusable data. So duplicating survey on a poll is something that's now kind of a thing of the past. Now we're just verifying information. Verify, take a new picture, save, and move on to the next. And and we can move on without having to recollect the same information again and again. And realistically, and then better data quality. That's the linchpin for this entire thing. By restricting the types of information, the pre-populating default values, having drop-down menus, those types of things really reduce the number of errors our surveyors make while also speeding up their collection. And then, like I've talked about, with having a standardized format really allows us a lot more automation downstream. One of the advantages I don't think I mentioned was that for our clients, we can tailor these apps to their individual needs. So if they have some individuals who need to see one piece of information but not another, or vice versa, we can restrict who can see what data, what they're able to do with it, if they're able to edit it or download it or only view it. So that gives our customers a lot more visibility. It gives them a lot more functionality on their end just to kind of deal with the data that we've been providing.